Hi, this is Mr. Manley. In this video, we're going to look at polynomial division primarily. But before we get into that, I'm going to start off with this first topic, which is the factor theorem, which is certainly related to polynomial division, and you'll see why in a moment. I'm looking at this problem here, and perhaps you've read it already, and trying to determine if x minus 2 is a factor of this polynomial. Now, what does it mean to be a factor? For instance, if I had a 121 and I said, is 3 a factor of 121? Well, how would I find that out? I would divide 121 by 3 and see if there's a remainder. Of course, there's another shortcut method for determining that, but this is one way that we could do it. We could do it by division. Likewise, with this problem, a way of determining if x minus 2 is a factor of this polynomial is to divide the polynomial by this potential factor. And this is going to be the bulk of our discussion for this video. But before we get into that, if I have a factor in particular that is in this form, x minus something, then instead of doing the division, I can determine if it is a factor by plugging it in. So the factor theorem says that if I do p of 2, now notice if I have x minus 2, I put in a 2. If I wanted to check x plus 2, if x plus 2 were a factor, then I would check that with a negative 2. And then I simply plug it in to the polynomial. So this would be 2 to the 4th minus 2 to the 8th plus 3 times 2. That's not 2 to the 8th, that's 2 to the 3rd. 2 to the 3rd. 3 times 2 minus 9. All right, and let's see what we got there. We got 16 minus 8 plus 6 minus 9. And what is that? That is 24 minus 17, which does not equal 0. And that's what I'm interested in. Because it equals 0, there's no remainder, and then 2 is a factor of the polynomial. Well, I shouldn't say 2. I should say x minus 2 would be a factor. Let's check x plus 2 as long as we have it here. And I'll try and go a little bit quicker here. So negative 2 to the 4th is 16. And then minus negative 2 cubed, that'll be plus 8. And then we'll go minus 6 minus 9. And that also does not equal 0. So that is the factor theorem. There's something else called the remainder theorem, but we will leave that for another time. All right, so there's the factor theorem. And you can see how that's related to polynomial division, right? It was like getting a result of polynomial division without actually doing the polynomial division. Here now, we're actually going to do the polynomial division. And I want to be pretty quick on this because I presume that this is a review. So this should look familiar, how I am setting this up, this long division. And then I'm going to say x times what is equal to 2x squared, and that'll be 2x. So I'm looking at this, I'm saying 2x times x is equal to 2x squared. So I was looking for a value here so that the product would equal the 2x squared. And then I'm going to multiply 2x by x. What I'm actually doing is I'm multiplying 2x by x plus 6, and then I'm placing that result here, right? And you should know all that. So let's go ahead and do that. That's going to be 2x squared and then plus 12x. And then I'm going to subtract this line from the line above. So 2x squared minus 2x squared is 0. 19x minus 12x is 7x. And then I'll bring down the 37. Now I'm looking at x times what is equal to 7x? And that, of course, is easy enough. That's 7. 7x plus 42. You see where I got that, right? 7 times x plus 6. I'll subtract those, and that'll give me 37 minus 42 is negative 5. And that's my remainder, because x I cannot divide into negative 5. Now we could write the remainder in two ways. I could just say remainder negative 5. Okay, that would be one way to do it. Now that looks a little confusing because it looks like r minus 5, but I'm saying remainder negative 5. And then another way to do it would be to say I can add the remainder over the divisor. So that would be another way to deal with the remainder. Okay, so let's move on to a couple of other examples. We have this example here, 2x plus 2. Actually, before we go on to that, let's go back to this, and I'm going to do what I think is reminding you of another method of doing this, with the method of synthetic division. In synthetic division, I start off with this box, and I place a number in the box based upon the divisor, here negative 6. So if I'm dividing by x plus 6, a negative 6 goes in the box. For instance, if I divide by x minus 2, then a 2 would go in the box like so. So understand how the box works based upon the divisor, x minus a number or x plus a number. Essentially the opposite, right? Then I'm going to look at the dividend, and I'm looking at just the coefficients. Here, 2, 19, and 37, and I'm going to list those next to the box. Then I go through this process. I place a line here, drop the 2 down. So the first number comes straight down, whatever that number is, that comes down. And then I'm going to take that number and multiply it by the number in the box. So in this case, I'm going to go negative 6 times 2. That's multiplication. I get negative 12, and I'm going to put that under the 19, proceeding from left to right here. I add down this column, so I'm going to go 19 plus negative 12 and get 7. And then I'm back to multiplication, negative 6 times 7, which is negative 42. And that moves into the next column, add down the column 37 plus negative 42 and get negative 5. Now this is the quotient and the remainder. Now how is this the quotient? The number that I start off with in the dividend, the 2x squared, that's what's going to drop down by a degree. So I'm going from x squared to x. So I go from 2x squared to 2x, and then I keep dropping down from there. So 2x, and then the next one is x to the 0 after I do the 2x, and that will be, of course, just a constant, the plus 7. So I get, in this case, 2x plus 7 with the remainder of negative 5. The last number in the column is always the remainder. And again, we can write that as remainder negative 5 or plus negative 5 over the divisor. And we see that I get the same results as I did with the other method of division. So that's synthetic division. Okay, so we'll go back to this one now that I was going to look at before. And the deal here is that I don't have x minus something. So I don't have that form. I've got a 2x. So I can't use synthetic division here. Therefore, I'm going to go back to the method of long division and set it up with the dividend and then the long bar and the divisor, the dividend under the long bar and then the divisor to the left. And we could go through that process of long division, as we've already seen. Okay, here's another one. And this presents some new difficulties. Again, it's not in the form x minus c, so I can't use synthetic division. I'll just take the divisor, the 3x squared, negative 3x squared, plus 4, and I'll set up a long division with that. Something to notice with the dividend here is that it's not ordered correctly, right? It's not highest degree to lowest degree. So I've got to be sure and reorder it like that when I write it under the bar. So x to the fourth, that's the highest degree, so I want to start with that. And then decreasing degree, x to the fourth, x cubed, x squared, etc. So I get to the constant at plus 7. And then I'm going to go through my process of long division with this divisor. So negative 3x squared times what is negative 15x to the fourth? And it's going to be 5x squared. So that'll give me negative 15x squared. Negative 15x to the fourth. And then I'm going to multiply that by 4 and get 20x squared. So 5x squared times 4 will get me 20x squared. And notice that I want to move that over. Be sure and skip the x cubed and place the 20x squared over 1. So don't put it under the x cubed. Put it over under the x squared. And then subtract this line. I always like to write minus with the parentheses. And subtract the line. 9x cubed minus 0 is 9x cubed. And then 14x squared minus 20x squared is minus 6x squared. And you should be able to continue from there. I just want to